Probability, again, it's all probability. Okay, the probability of harmful consequences or expected losses. Okay, the probability of expected losses. What are those losses? They could be deaths, they could be injuries, property damage, livelihoods, okay, economic activity disrupted or environment damaged. Okay, pretty much everything that actually what we have considered in the, because these are the elements at this. Okay, we have economy, we have environmental, we have physical, we have another one is what? Social. Okay, now these expected losses resulting from interaction between natural, human induced or man-made hazards and unfavorable conditions in a given area and time. So that means definitely risk is a function of hazard. That's time and space is coming there. Okay, vulnerability because you have all the components there. Plus quantity because how many, how much. That is what actually defines the risk. Okay, here I have given some examples here. From images, when you have resolution satellite images, you can derive some elements at risk like building populations. Okay, and from population data also you can derive population density. Okay, and so on. Watts, census, from DM, you can all those data you can derive actually different types of hazard now, right? Like landslide, flood hazard, or any technological hazard or any earthquake hazard. Okay, and these, how do we perform? Just now we learned about either numerical, either statistical, or either deterministic or data-driven based approaches like machine. Okay, and risk is a function of hazard multiplied by quantity multiplied by time. Okay, and it can be defined quantitatively and qualitatively depending on what kind of data. Okay. Quantify. You do the quantitative aspect when you have a good amount of data. When you suppose to do it very poor quality data set. Okay. But when you talk about the risk, there are direct losses. There are indirect losses. Right? I have given you some examples in my previous lectures. Right? If there is a hazard or hazards happen, or expected hazard is always expected. If someone cannot do the work, okay, there is a direct loss obviously because there is no money. And there are also direct losses as well. Right? All this that we have to calculate. And when we say direct loss or indirect losses, it can be tangible or it can be intangible. That means which you can quantify or you may not be able to quantify, but there are intangible losses as well. Right? Intangible losses means what? The well-being and all those things that you can't quantify. Right? Then you have the private losses, public losses obviously. You can be now, forget about this. Risk assessment, just actually focus on this underlying one. One is risk analysis and risk evaluation phase. The risk analysis is basically whatever information that you have for individual or population or property or the environment that is arising from the hazard. That is what we call risk analysis. Risk evaluation is basically more an alternative approach, for mitigating the risk. That means what? The stage at which the values and judgment enter the decision making explicitly or implicitly by including consideration of the importance of the estimated risk and the associated societal impact. So it's like an estimation. Okay, but this is the actual analysis that is. So basically risk assessment you have both components. So if you go for risk management, you have the big box is the risk assessment, and in the risk assessment there are two. One is the risk analysis and you have risk evaluation. Risk evaluation you do based on the risk analysis. Right? It's a judgment that you give. Okay? And then Obviously, risk analysis, all those things that we have already learned. Hazard identification, hazard assessment, element at risk, exposure or vulnerability assessment. Okay? Then obviously you do the visualization of the risk, whether it's through maps or through the curves. Okay? Like in the vulnerability curves we have seen, also it can be defined as in terms of curves. Once that is done, then you take it to the mitigating measures. Like whether it will be non-structural or structural. Structural means in the earthquake, we come up with the codes, building codes or some kind of standards, right? In the non-structural, planning, awareness, then other early warning and preparing the community, giving those kind of knowledge transfer, okay, all those kind of things. Okay? Imagine this. If you want to define the risk, look at this. Nice holiday home. Isn't it? Very nice holiday home. Looks like Krishna's waterfall. Mesa Hutes. No one says that. Mesa Hutes basically one Western Ghats. Because it's volcanic rocks. Volcanic rocks basically over a period of time get better. Then you have to Mesa Hutes, right? So risk quantifying the amount. Okay. This I have already gone through. We don't need to show this. Okay, many times. The reason why I am actually putting all this repeatedly, you should not forget. Those are actually like the Bible and Gita and the Quran of the risk assessment, or just the risk management. Okay. So this I already explained before. Hazard explained, vulnerability explained. Look at the element at risk. What are those? Already mentioned to you: population, property, economic activities, public services, or any other defined activity that is exposed to hazards in a given area. What we call assets. Okay, element at risk is called assets. Amounts of element at risk, like quantifying them, the quantification of the elements at risk. How many buildings, how many people, in terms of money, okay, how much, investment values, right, cost and etc. And also some perception about the element at risk as well. Okay, that is called AES. Another term also is called consequence. Consequence is defined as the expected losses. That means the quantification type is written by A. A is what is A? What is A? Amount of element at risk. Okay. In a given area, a given hazard scenario. That is the consequence. That means specific consequence. Alright? That means specific consequence due to a specific hazard. Okay? Understanding? Then you calculate the specific risk. Specific risk again is a function of what? S, HS, VS and AES. What is HS? What is HS? What? HS is? What is SS? The probability of hazard. Right? Then VS is vulnerability. Then AES, amount of element at risk. Same. And then you calculate everything with the total risk. Like how we calculate the total vulnerability. Okay? Summation of all the type of this that you get into the total risk. Alright? Let's look at this case. In GIS, there are many ways actually you can produce the risk map. Very simple overlay based risk map to very detailed quantitative risk assessment. Okay, in this case, this is a simple overlay. These are elements at risk. For example, all the housing area. Now, I have already prepared the hazard map. That means the spatial footprint of the hazard. I just overlay. Simply I just identify what are the areas that actually are on the list. Simple overlay. There is no calculation there. Just the visual inspection. Okay? That is still considered as simple risk assessment. Okay? Isn't it? That means we take the hazard footprint for a particular event and we took the element at risk, and that then will produce actually the element that has been at risk affected. Okay? But in this case obviously we didn't take the vulnerability. Did we? We didn't consider coping capacity. We didn't consider all those things. Physical vulnerability. We didn't consider structural, all those things, right? And this is usually one of the preliminary stage when you want to do the risk assessment. When nothing you have, not much data you have just actually your hazard map, and then you drape it over actually the element at risk, at least it can tell you. Or drape it on, let's say, your land use. It tells you, these are the areas going to be flooded, and these are the areas, whose house is that, all those things. Okay? Analysis methods, two types, qualitative and quantitative. Okay? What is qualitative method? No quantification is done of the probability. It's called also relative risk. That means normally they put it actually matrix format, maybe graph format. Okay? Or this is why the multi-criterion based approach they use. Okay? Multi-criterion based approach, that is the qualitative based method. Okay, but where in the quantitative, digital and simple risk analysis we can do. You can use also numerical based modeling, deterministic based modeling, probabilistic modeling, and it is very, very detailed. And it requires you actually data as well. Okay? Understand? It's not rocket science. This is a simple risk matrix that in the qualitative risk assessment. Okay? In the x-axis they put the potential loss, in the y-axis they put the probability. Probability is from very low to high, potential loss from low to high. And then they put actually in the risk matrix, define the combination of the two risks, two at a particular risk. For example, AAA, this is very high, right? Okay? This is one way of actually defining the risk as well. Qualitative assessment, multi-criteria based approach. Okay? That means you have got 20 people, they have given their inputs to questionnaire. Then you derive actually this kind of like very low to high. So everyone you just put them, put in the matrix format. If all of them say very high, verify one particular type, which is very low. Okay? Right? Simple. This is, see, there is another way also. This is another example of the susceptibility also. I have already given the example of, let's say, if you are taking the export document, that's the best way to explain this. Okay? Quantitative risk assessment, obviously, you have to follow the equations. That means hazard and amount. Okay? That means hazard you define spatial footprint. Vulnerability, you come up with the vulnerability map, different types of vulnerability map, combine them, produce actually the total vulnerability map, then you calculate actually the amount, how many buildings, how many people, and so on. That is what actually gives the hazard. Risk. Okay? Okay, this I will explain. This we can already too much for you. Okay, this is one example. See. Construction of risk map. Okay? You have inventory. Imagine in the case of landslide, because you have we use the landslide data. Okay? So this inventory. Then all the value parameters that you have, and then you produce actually the susceptibility map, and then you produce the hazard. Okay? Bring in the triggering factor. This is the susceptibility. Bring in the triggering factor, you produce the hazard map or hazard index. Independently, now you are also producing the physical vulnerability, social vulnerability, economic vulnerability, and environmental vulnerability. Right? Then you produce the total vulnerability index. Multiply with both of them, you come up with the risk index. If you have the amount, you can stop still here, but it is not purely quantitative. It is not telling you the dollar amount. It's not very easy to get those kind of data. stop here as well. You still can produce a risk. Okay? And then, based on that, obviously, you can do the mitigation plan. This is a very good example. Huh? Yeah. This is one thesis. 4 years thesis. Okay? You can do also for all these kind of geohazards, flood, landslide, and so on. Okay? Forest fire, etc. etc. Flood risk normally calculated for what? 5 years, 50 years, 10 years. Okay? You see, when you calculate every type of what you call return period, obviously the hazard footprint actually, the risk footprint is changing, right? This is for 5-year return period. 50 years. How many of you are familiar with plot modeling? Okay? So we don't talk about it. Okay, I think we can stop here because I've already mentioned all these things. If we have more time, we will have to look at practical. Okay, any questions that you have? This also I have already explained to you yesterday. Remember? That building, particular building A, B, C, and what is the vulnerability on? Okay, then we calculate the amount. Remember? Then we can quantify the value of the house and we can quantify the risk also. Okay? The risk of. Okay? It sounds easy, but it's complicated depending on the type of geohazard, right? Because, see, this is in the case of landslide. Here is the spatial probability of slope failure, okay, which provides the risk for this. Okay, then you are calculating the degree of damage. Okay, then here it carries different risk. Here it has different hazard. It's a different hazard. Here rockfall. Here whole damn thing can actually move. Okay, and what is the risk? Right? Here you calculate the volume, different type of landslide. Then this also material comes and also gives the risk here. Right? So it's not a very straightforward process. In a complex scenario like this, why would you want to build a house like this? Nice view? Nice view? Yes, sir. Okay? Any questions you have? Shoot, any questions? Let's have a discussion. Let's discuss. This also I already explained also. Yes. But now में क्या लगेगा तुमको? Crops. Okay. Then you have to first estimate the yield. Then quantify actually the yield. How much? Okay. Then you translate it to dollar. Right? Then you bring into the risk. And for different type of crops, obviously, your dollar value is going to be different. For maize, it's going to be different. For rice field, paddy, it's going to be different. So, therefore, one of my early lecture I mentioned for each particular type of hazard must be very specific what kind of data that you want to get. That is why the literature review is very deep. Why do we do literature review? Literature review, why do we do? Because you are reviewing the existing body of work, and then summarizing it there actually you are creating some problem statement. Right? A good research is not like filling a small research gap. A good research means not that someone has done something, left a little hole, and you are going and putting a patch on it. That's not a good research. Because then, when the patch is filled out, you are done, you are finished, you cannot take that volume of water. Okay? Methods are not that critical. Methods can be learned. Nowadays there are courses, crash courses on Python, crash courses on machine learning. The most important thing having the foundation, fundamentals. Okay? That's very important. So, why do you call research? Research. One such. चार साल 5 साल लगे रहो, जिंदगी भर लगे रहो, अभी लगे रहे। Even your tech, try to find a good place, not just actually getting a certificate. You know how I got attracted to this field? Geospatial. I didn't tell you. I didn't know that. So obviously those days there was no GIS. But in your MS, then obviously there is a requirement to do actually master. Yes, sir, this is like you guys. So I wanted to do something on the groundwater. So I think my thesis is one of the early theses on groundwater potential mapping using GIS Remote Sensing data in this country. Although I didn't publish that book at that time, because as a young student like you, who cares? You are wrong with the sun. You are interested actually in the companies, campus interviews, and all that the IIT was moving. That time, 30,000 rupees you are earning, which is fantastic. Yeah, it's a salary. Professors will be earning around 50,000. Okay. So, when I took that subject, and then I was not introduced in that subject. But I was vaguely into morphology. I have learned that. And geodesy obviously we had. Okay, but geodesy is totally different than all these things. There was no GIS per se. Okay. So, GIS was something new. But when I started working on it, I got so much engrossed and intrigued by this. I thought this is something that I should do. And I wanted to learn more because it was not enough. Therefore, then I went to actually company. At that time, they had digital image processing like that. Still have. In civil engineering department, we had some remote sensing, such as processing and things like that. It was my favorite areas. I remember the Indian Journal of Society of Remote Sensing that used to be run from my lab. There's no PDF that you get at that time. We used to communicate. My first paper was communicated by hard copy. 2 sets of hard copy of the paper were printed, sent actually by post to the journal. Whole process takes about 6 to 8 months, 1 to 2 months. And we used to eagerly wait for one volume of the new volume of the journal to come in so that we can go print out, the photocopy, print out. Printing out so expensive. Those days, if someone has an AC, air conditioning in the lab, it's considered a very rich professor. Color printer was also very expensive, and we deal with all kind of images which require you to do documents, interpretation, and all that. So that intrigued me, and my professor at that time, he told me, "What is GIS? Go into remote sensing, but this is better." ISRO, NASA, from my lab, NASA, but I like this partial stuff because I thought that a lot of things can be done here. So despite my professor not encouraging me to go into this, today with the GIS that you see today, we have when there are not enough things, there are opportunities. Okay? Right? So it is when you look at opportunities. If everything is given like a platter, still going to figure it out. I have one. And subsequently, that paper also I published. The groundwater potential is in segment. Yeah. Also in Bharat actually. Because it was new, right? The old damn thing was so new at that time. So kind of why I got into this that fellowship that was new at that time. And so much of risk going into that because not knowing what is the future going to be. You're going to miss out your campus. IIT Bombay I left having two jobs, campus two. One is Tech Mahindra, another one was well paid. And I knew the rest of my life I have to keep on learning actually codes, which is not done in software engineering that. Although I had good amount of coding knowledge. Because we were trained actually for Pradhan. I don't know we were trained. I don't know whether you are doing programming coding or not. First, when you go, we had advanced maths with all the V.G.K guys, and then the coding. Fortran, C, Java. So, see, risk is there. Not knowing you are going actually to, and what is DAD was, I think we are the second batch. Today DAD is very famous, right? That time was second batch. Not knowing when you come back what will be the. अब इसको बंद कर दीजिएगा. Not knowing क्या होने वाला है. Because anything that you publish in your घर पे भी कुछ कहीं डाल दे वो भी उसका. That's not reliable. Okay, first I am telling you where to search. Okay, and how do you define actually, for example, if I am interested to work on groundwater contamination assessment using machine learning. Okay, using machine learning and GIS. Let's say this is the topic that you are looking at. Now, what are the index terms that you come up with? Obviously, groundwater contamination is the first one. Then I would put and, not what, and machine learning and GIS, remote sensing. Then you see that what are the fields are. Then quickly go through, review, very quickly, don't waste so much of time. Really, from the title and from the abstract doesn't make sense. Is it something that is interesting? And I would only go for the last 5 years for that. Okay? पुराना चीजें क्यों देखना? Already हो चुका है. आज 5 साल में क्या करना? Okay? Fifth, then I would make a catalog. Okay? After that, now coming back to the question, how do you read a catalog? During my PhD, it took me to understand market for 6 months. It's very, what do you call, I feel shy to talk about it, but that's what it was. 6 months to understand this market. My PhD thesis was lossless compression of digital elevation model using second generation programs. That means, because at that time the data size was mattering a lot, I wanted to compress the data without compromising on the quality of the data. And mostly it was actually distant elevation model. So I I developed the entire code. Okay, and I think the code itself can be a thesis, because nothing was there, right? So I had to figure it out how to do the triangulated irregular network in Fortran, and then bringing in these wavelets and continuous wavelets, calculating all that. There was only one paper at that time was published from, I remember the surname was something Srinivas, Sri Lanka, but US. So that was the paper when I read, and that is the topic I wanted. Because I found a lot of things that were knocking down. But obviously after that I didn't actually, right? I jumped to geohazard, which I did in my So now coming back to this, 6 months took me just to understand that also 20-30 times I have written the author, because they don't provide everything. One step, then 3 steps are missing. So first you would like to replicate what has happened exactly in the paper. Then only you can think what will be done, how to take things. So when I read a paper, first important thing I read just the abstract. And I would be worried about anything that's happening. Because abstract gives me the entire gist of the paper. Conclusion gives me the finding of the paper. And every paper also writes something called limitations. Right? Look at the limitations. What are the limitations that I have? Can I enhance them? So let's, and you want to replicate what are these models that you can use, and you want to use it in your work. Otherwise, all of it is at least 200, 300 papers. Okay. So I think we stop here. We have
headquarters in IIT. So we are planning to establish here a local center here because we already have approval of it. So for that purpose we need 50 live members, right? So IIS works for the advancement of the fields related to water resources.
So we are making NIR with some red. These are the bands you know, right? NIR, red and some band. Or let's make FCC. And what does it mean? False color. This is false color. So 3 bands are required. Okay, let's not do that much. Let's take NIR and red and make an index. Let's say vegetation index some ADVI. Okay, everybody knows this is a vegetation index. We have to mix this to band and we have to make this index NDVI. How NDVI is made? NIR minus red by NIR plus. कुछ नहीं है, बस खिचड़ी बनाना है, दाल और चावल है, दोनों को मिक्स कर रहे हैं, खिचड़ी बन रहा है, ठीक है, कोई टेंशन नहीं। ये इंडेक्स है, ये NDVI। So if we want to make NDVI, what we have to do? We have to download a NIR at first. Then we have to download red. From where we are downloading QSGS. So from this website or Art Explorer, we have to download all these images, NIR, then red, right? Then we have to process all these images, right? So let's assume that this is our study area. This is our study area, right? So we are downloading some images. The images looks like this. These are the grids. This is another grid. This is another grid. And this is another. What are these grids? These are IOP, instantaneous field of view, जो जिससे हम लोग scan करते हैं with the help of that. So these grids are downloadable in HDF format. So in HDF format we download all these grids. What we have to do? We have to download 1, 2, 3, 4. 4 grids we have to download. Okay. So we download 4 grids. Then what we have to do? These are interpolated. So we have to mask it. At first we have to join it. Then we have to mask it. Then what we get? We get for this study area we get our image. How we get our image? We need this much area, right? So this much area we need. So the first step what we do? First step is we download 4 tiles. We download 1, 2, 3, 4 tiles. Then what we do? The second thing we do, we mosaic all these things. So apply mosaic. What the mosaic will do? Mosaic will make, these are the 4 tiles. These are the 4 tiles. What the mosaic will make? Will make like this. So all these images will become one image. After that what we do? We crop this image. What is this called in GIS? Masking. So we mask. Right? We mask it. With the help of this, we get only NIR. After that, for red also we have to do the same process. Right? And each and every image we are downloading in HDF format. So each and every image will take 230 to 500 MB space. And the ultimate image that will be made for ATBI, we get ATBI like this. Let's say we get this is the ATBI. What is the size of this image? The product, let's say 20 MB or so. So we have to process 230 MB into 8 images we have to take. So 2 GB's space we have to take, and we have to process everything. Then we get 20 MB. Right? In GIS, ArcGIS, if we download from USGS and we process, then that much what we have to do. So what we are going to do in Google Earth Engine, we have the database in Google Earth. We process that online. We just download this 20 MB by just writing 3 or 4 lines of code. All these things are done in Google Earth Engine. We do not have to download this, handle all these huge files. We just do the process in Google Earth Engine and we get the ready-made product. So this is the power of Google Earth. Any issue after that? No issue. So let's start. So this is the basics of Google Earth Engine, why we use it. We are searching in Google Earth Engine. The first thing is come Google Earth Engine. We are opening it. This looks like this type of interface. Platform, data set, non-commercial, commercial, time lapse, everything is there. What we go to the data set. Okay. You can view all the data sets that are available. Models, Landslides, Sentinel, each and every data set you can learn from here. You just have to do some work on that. So data sets, whatever data sets we are using, we must know each and everything about the data set. Otherwise, the comments may not work. So, the programming what we have to do, we have to go to platform, then code editor. Whenever first time you open the code editor, it will say you to open an account. So, I already have an account. So, this will look like this. Okay. So, this is Google Earth Engine and the interface looks like this. Here we can see three platforms. This one is for data. For input purpose, we use the left side. Then for output purpose, we use the right side. Clear? So for input purpose, we use the left side. For output purpose, we use the right side. In the middle, there is the script. We write the program. So whatever we have to give, whatever we have to deliver, we have to give there. We get the output in right side. So let's come at first in the input side. Input side, what we can do as a computer we can do some folders. In the folders we can keep our files. All the files remain safe in our G.K. So you do not have to worry about anything. You just work over here and everything will be safe. Alright. Now docs. The docs are the libraries. From here you can know about each and every command. If you want, you can know from here also. So we require maximum 3 or 4 commands that will be deliberately used. Okay. So if you know 3 or 4 lines of coding, we can use it repetitively and we can do our work. It doesn't have any rocket science you have to do or any high-level programming. So 4 or 5 programming language you must know. Comments, that's it. And if you require anything, to know about anything, you can learn from the library. This is the library. We have the library here, and in the library everything is there. There is nothing out of this library. So whatever Google Earth Engine can do, everything is here in this library. Okay. So in the script we can get our folder. We can call it file manager something that we use in our mobile or in our computer. So this is our file manager. In the script we have that. You can see in my file manager in script you can see all these folders are there. Basic lesson 1, basic lesson 2, basic lesson YouTube. These are the folders. And within these folders there are many files. These are the lessons. And these are the project I am working on: flat data, grace image, mean DEM, March SHP, Sentinel. These are the projects I am working on. So basic lesson 1 we are going to work. So everything is filed up in this one. I do not have any extra pen drive or anything. Everything is saved here. So you can save your work here, and you can work anytime, anywhere you want. If you want to work from outside also, you just log in your Gmail ID and you can work. So nothing extra you need. Alright. So this is the file manager we have. This is the library we have, and the asset part. In the asset part we can save files, right? So in the asset there is new. If you click on new, they said what you want to save. The GeoTIFF, so image you can save, the shape files you can save, the CSV file you can save, image collection you can save, folder you can save. So they are giving you a database also where you can save your data also. So I want to show my asset files. There you can see 7 villages, Bakura, Bihar, these are the asset files. What are these assets? These are the shape files. Whenever I require these shape files, I do not go to my computer or anything. You can go to your computer and upload here. But once you have uploaded here, you can use that repeatedly. So I am not extra using another source of folder to use this. I just use these memories to use work. Okay. So these are the inputs. Any question? Any questions on the input? Okay, so we have seen the file manager, the library, and the assets. That's it. Completed? Okay. So the inspector. In the output, we get the inspector, the console, and the task. I will show each and every word in application also. The inspector will give you, if there is any problem in your coding, the inspector will help you to find out what is the problem. In the console, you get the output. Okay? In the console, you get the output. In the task bar, if we give any command to the output, we can do the task here. What is the command we give to the output? Suppose we want to download a image. So we are giving the command to export a image from Google Earth. So what this task will do? In the task they will say in which format you want, where you want to save this. So in task bar we get the run program. Okay, so I will show. Then it will be clear. So this is the output. This is the output part. So let's go to the fast script. So this is my fast program. Okay. This is the fast program. So we are coming one by one. The imports is showing 3 entries. The import is showing 3 entries. What are the entries? These are, first one is the satellite images. Right? The second one is the shape. And the third one is the parameters. How we import this? Let me show you. There is a search button. In the search button, maybe we require an image from any satellite, say MODIS image. So we search at MODIS. And they give us enormous amount of MODIS image data. So from here we get the MODIS image. Okay. So let us take MODIS specified image like MOD21C2. So this is MOD21C2. So this is a specified MODIS image. So this is a land surface temperature image. Okay. So this is the image MODIS. This sensor I am using. MODIS T1 sensor we are using. So this is the database I am going. So this is Terra satellite. What we are taking. MODIS 21C2 is a database where you can get land surface temperature. लैंड सरफेस का टेम्परेचर देखना है ठीक। तो इसमें क्या क्या है देखिए, डेटाबेस अवेलेबिलिटी ये 2000 से डेटा हमारे पास है। वी गेट द डेटा फ्रॉम 2000 to updated, right? So database provider and database collection. So this is the code they are giving. If we take this code and put this, already we have this in our script. So they are already giving us the code also. So you just have to copy this and you just have to paste it in your script. Okay. So I am not going to paste it also. What I do, I am just going to. Okay. What I do, I just put the import. Here it is given import. I just click on the import. It is imported. You can see I have 3 imports. Now I have 4 imports. So I have 4 imports. Now I can change the name of my variable. Here it is written image collection. I can name it Nitish also. Anything I can name it and I can use it later in our folder. So it must, if I give it Nitish, we have every time we want to call this data set, we have to give that Nitish name. So it must have a logic behind it. If it doesn't have any logic, then we may deviate from the. So it is the LST product we are taking, so we name it LST. Okay. So if we name it LST1, so this is how we can import satellite images in our Google Earth. We already have that. You can see image collection 727 bands. So we are deleting that. In the left hand side there is a delete button. We just delete that. So we already have that. This is how we can import the database completely in our script. Understood? The satellite images database we can import in our script like this. So this is the only program we are going to do today. There is nothing to issue. Now we are going to import our shapefile. So go to asset. If you do not have any shapefile, go to new and go to shapefiles, and you can select the shapefiles from your computer also. Now I have shapefiles, so I am going to Bihar or something, West Bengal. They will show this is the shapefile you want to import. They are showing this is the shapefile you want to import. I just click on import. Once I import it, it will show like this. It is showing the table. So once again we have to change the name. From table we have to name it West Bengal. So we have named it West Bengal. Name must be alphanumeric and start with letters. There must not be space. So there must not be space. I have given a space, so they are giving the error. So we have named it West Bengal. We already have that in the second position, so we are deleting this. I am showing you once again, and we have the variable WP. So it is West Bengal we already have, so we are deleting this. The parameters I will show you later. So what we have imported the satellite data. Yes, we have imported the shapefile. Now we are ready to go for code. Okay. So the first what we are doing, we are taking the first image of LST. Why we are taking the first image of LST? We want to know the properties of this image. Whatever we are taking, we must know the properties. So if you know all these things, all these coding lines, if you get any error, you must check with these lines that what are the properties that have. If you are doing any error in the coding, so these are the check lines. We can check everything with the help of these lines. So let me run this one. This complete code, let me run this. It's 5-line code, it's not that much. So okay. So the code has run. So the first thing we have done, the first image. We have taken the first image. What we have given? We have given lst.first. What is LST? LST is our database. Database name we have given LST. So the first thing we have to do, we have to ensure our database. Then dot. Then what we want to give. If we give here some other function, this is passed, and the brackets are the functions. So this is the function we are implementing. So LST is our database. Dot. Then the function we are implementing, and it is giving us the first image, and the first image name is saved like first image. Okay, the name is first image, the first image is saved. The second thing what we do, we are giving a variable name, band names. What is the band name will do? The band name will give the band name of the first image. The first image band names we want to know. Then we print the brand names and we get this result. These are the bands we have. 0 to 26, so 27 bands are there. So they are giving us the band names. Alright. So we have taken a collection of images. We take the first image and then we are checking the properties of the image. Okay, and everything we are doing with the help of simple one-line code. Okay. So if we take the first image and we have taken that there is 27 amount of bands. What are the bands we require? 2 or 3 bands. So from the database we will export 2 or 3 bands, then we work on that. The first thing we are doing that, band names is done. Now we are taking LST size. Print LST size. What the LST size will do? LST size will tell us what are the amount of images we are working on. So So Google Earth Engine do not have the capacity to work 5,000 images. You have to compromise with 500 or 1,000 or 5,000 images. So Google Earth Engine is not ready for a lot of pixels to work with. Whenever you work for a larger database, you have to work that in part by part. So this is the compromisation you have to do with that, but this is still more powerful. So whenever we are giving this print elastic size, it will give us 1140 images elastic. So the modis elastic have 1140 images. Alright. Now what we are doing? We are selecting LST day. Okay, LST day we are taking from this. This is the fourth band we are taking. We are only interested in LST day. Okay, one band we are interested in. We have taken this. So what we have done? We have introduced the data set and we have given the command. What is the command? Select. Then what we have done? In inverted comma, we have given the band name. And we have exported one band from the total collection. That's it. And add to map layer. What is map layer? Map layer is this one. This is the map layer. So we are in the map layer, we are adding this. Okay, you can see there is a blue and yellow things are there, right? But now it is not there because I have taken the complete world. Yes, it is coming. I have taken the complete world and add this in map layer, so it is coming very slow. When I crop this image, when I import the shapefile, it will come very fast. Okay, so this is the map layer we have. So it is already showing that these are the cold places. This is coming as blue. These are the hot places. So it is already showing something that LST daytime data. That's it. So this we can do. This is our task today, and I am showing some extensions what we can do. So this is our task today. We will do that. Up to that we will do today. So this is if you can do this 4 line codes, you are ready to go, ready to start. Now I am showing you what we can do with the help of this powerful tool, some applications and so on. So we can import the raster. So this is the program. What we have done? This is the fast program. We just added the shapefile here. And after adding the shapefile, if you run this, it will only show the shapefile. Okay. It will not show the whole area, whole world. It will show only the shapefile. So from here, there is layer option. So we can change from here also the ranges. This is the parameter part, what I am talking about. Here variable parameter is given. This is where when we click on the import, that parameter part will be imported. Okay. Everything is graphical user interface. You do not have to write the coding of the parameters. If we search in some ChatGPT, or they will give a long code of parameters. So we do not have to do all these things. We have to visualize this in the map part, and we can import it easily. So we can do this also. And this is the just one image I am talking about, right? So LST fast I have given, and we are doing the coding for the one image. If we want to do for a lot of image, for 1 month of image or for 1 year of image, what we have to do? We just have to write a code that has a loop. This is for image collection. So what is the loop we are giving? This is the function we are creating, and we just made a loop. So for this, if you create this function, we can easily work with image collections also. Okay. For exporting image, there is just these lines. You do not have to every time write these lines. Once you have these lines from any coding, you can just pick from there and you can export your image. Alright, for one image this is the coding, and for exporting image collection you have to run a loop. So this is the loop you have to run for exporting image collection. Once you have written this code, you can use it for lifetime. So you do not have to worry about this. For exporting image collection, this is the code. Okay, so right now I am showing you here, if I run this code, okay, the scale is not 1000, okay, there is a scaling problem. Yes, they are saying here that unexpected token, there is some error. What is the error is here? Here I have given the scale is 1000, but the image do not have 1000 scale. It is a modest image, so it is 30 scale. So we can give here 30 and run this program, but I do not want to edit this, run this. If this also gives some error, then we have to edit this. Okay, so this has run. So there is export, and once we have done export, what we have to do? We have to go to task. In the task, they are saying that LST day filtered image is ready. Once I click on run, it will be saved in our Google Drive directly. So the image is ready and it will save in our Google Drive. We have to download from our Google Drive. It will be there. Okay. So that's it.
But you have to make sure that there is empty space, enough space in your
Google Drive. Yes, if there is not enough space in your Google Drive, then okay. So these are the names and something we can edit also in the export. So the first program we write, there is no issue. We just import a raster data. Okay. This is the program we do. So everybody, what you can do, you can start making your account for Google Earth Engine. You can do it in your laptop also or in your desktop. Just make a Google Earth Engine account and we just make a simple code with the info that we can learn. It's very easy, just 4-line code we are learning. Nothing more. Google Earth Engine, just search in Google. Okay.